In this problem, we're given four different functions in various forms and asked to find several function compositions. Before I start, let me remind you the relationship between function notation, graphs, and points. With function notation, we always put the name of the function out here, like I called this f, but you can see that in different places they're going to be calling it g, h, or p. And whatever we put inside the parentheses here is considered the input of the function, and whatever's out here is considered the output. If you're given a graph or a point, it's always the case that the input is the first coordinate of the point and the second the output. This will be useful when I do these problems. For example, the first question says to find f of g of negative 4. So we write that down, f of g of negative 4. So even if you've never seen function composition before, you should be familiar with g of negative 4. So here they've called the function g, but the notation is still the same. It would be g of input equals output. So the fact that they put a negative 4 in the parentheses here means that negative 4 is the input. So over here I'm just going to work on the problem g of negative 4 to start with, and I need to find the corresponding output. So negative 4 lines up with input. I need to find the output. So if you look at g was given as a set of ordered pairs. As a point, negative 4 is going to be the first coordinate, because as a point, the first coordinate is always the input. So I'm going to go and I'm going to find a point. It looks like it's the first point in the list that has negative 4 as the input, the first coordinate, and it says if you plug negative 4 in, you get 2 out. So the fact that negative 4 comma 2 is one of the points in the set g, that means g of negative 4 is 2. Well, that means I can substitute this notation that says g of negative 4 with the number 2. So I'm going to do that over here. Where I see g of negative 4, I'm going to replace it with the number 2. If I replace all that with the number 2, I still have the right parenthesis here, the left parenthesis, and the letter f. That means I'm not done. I still need to find f of 2. So now I go to the graph, because the graph is the one whose name is f, and I'm going to find the point on the graph that has 2 as the input. So I'm looking for a point on f. I'm looking for a point on f that looks like 2 comma something. So the fact that 2 is in the parentheses means that 2 is the input. That means it's the first coordinate of the point I'm trying to find. So I'm going to go over here, I'm going to go over 2 units in the x direction, and if I go up I don't hit the curve, so it looks like I'm going to have to go down. I have to go down 3 units over at negative 3 to find the output. So if I had to label this point right here, it would be x is 2, y is negative 3. So it looks like 2 comma negative 3 is on f. That means that f of 2 is negative 3. So I'm done with the problem. I'm down to f of 2. I found that that was negative 3. That's the final answer. So if this was a homework question or test question, you'd want to go back and rewrite the original question, f of g of negative 4, and then say that it was negative 3. The next question, g of h of negative 2, involves h now and not f. So h was given to be an equation, so it's going to play out a little differently, but the rules are always the same. So I'm going to erase my screen here, and I'm going to write the next question, g of h of negative 2. G of h of negative 2, the game hasn't changed. If the number's in the parentheses, it's an input. The difference is now that the h was given to me as an equation. So I have that h of x is equal to negative x plus 1, and I'm supposed to find h of negative 2. So if I write the question down with the given information, it's clear to me that where there was an x, now there's a negative 2. So this means please plug in x equals negative 2. Well, x already has a negative in front of it. So when you plug it in, it's going to be negative 2. I'm not sure I have room to write that. We'll just try. So negative 2, but then you still have the plus 1. So what would h of negative 2 be? H of negative 2 would be, let's see, 2 negatives make a positive, so that's positive 2. 2 plus 1 is 3. So all of that just to find that h of negative 2 is 3. Well, if h of negative 2 is 3, I can substitute all of these symbols here, h of negative 2 with the number 3, copy my right parenthesis here, copy the left parenthesis here, and that means I'm almost done with the problem, or half done with the problem. I still need to find g of 3. So just be careful. G is given as a set of ordered pairs, and an set of ordered pairs is nothing but a list of points. So if you look at the notation for points, it's always the first coordinate that's the input. So I'm looking for a point on G that has this structure 3 comma something. So I go up here and I find the point that has 3 as an input. So you might get stuck here, but be careful. This point right here I'm pointing at has 3 as an output. We don't want that one. So it looks like this guy over here, 3 comma 0, is the one that has 3 as an input, and it basically says 0 would be your output. So this notation means that g of 3 is 0. So that's my answer to the question. G of 3 is 0, and that's what I was left with here. So the question was to find g of h of negative 2. You could copy that down if this was a homework question or test question, and then write your final answer as 0. So 2 more to go. This is the first problem now that they've asked me to use p. So if you locate the function p, it was actually given as a table of values, which works much like points, except if you look at this function notation p of t, if you look inside the parentheses, they chose to put the letter t in parentheses. That means that t is the input. The fact that that's even in the parentheses means that t is the input. So over here, my top row is going to be my inputs, and my bottom row is going to be my outputs. So when I go to find p of f of negative 1, I don't know why it keeps switching like that on me. There's a little bug that's happening to me this morning. So just bear with me. I've got p of f of negative 1, and close that off. F was given to me as a graph, so we've done this one before. So I'm going to look on f for a point that has negative 1 as an input. Again, the fact that the negative 1 is inside the parentheses means that it's the input. So as a point on f, we want the point that has negative 1 as the first coordinate. So we're looking for a point on f that has this structure. So I need to move negative 1 in the x direction on the graph. So here we are at the origin. Move left over to negative 1. And it's clear to me the curve is down. So I'm going to go all the way down 4 units to negative 4. So if I had to plot this point right here, it would be negative 1, comma, negative 4. And the fact that that is a point on f means in function notation that f of negative 1 is negative 4. And this is where I make my substitution. Where I see f of negative 1, all that notation, I replace it with negative 4. So all of this stuff right here, that'll all be replaced with this guy, negative 4. Now I haven't done the right parenthesis, the left parenthesis, the letter p, so I have to copy that. So I've made all substitutions except for that. P of negative 4, p was given to me as a table of values. Don't forget that the number in the parenthesis is actually a t value. If you look at the function p of t, t is the input. So the fact that negative 4 is in the parentheses, in fact I can even line the question up with the general notation here and show you that you might get confused here, but t is actually negative 4 in this case. So we got that the input t is negative 4. I go over to the chart and I locate where t is negative 4, and the chart shows that if t is negative 4, you get an output of negative 2. So this right here says basically p of negative 4 is negative 2. So we've got p of negative 4 equals negative 2. So my question started with p of f of negative 1, and we did all that work to find out the answer is negative 2. The last question here, g of p of 2, I'm going to go over here and give myself some room to write. G of p of 2, let's see, we've used g before and we've used p before, so you've seen both of those formats. It's just a different question now. I need to find g of p of 2. So I start with the inside, p of 2, and if I line up the question with the general notation here, p of t, it's clear to me that there was a t in the parentheses. They're saying t is the input. Now they're saying that we're replacing t with 2. So that screams at me that 2 is the input. So again, I'm looking for where I get a t value of 2. And if you look at the function p, because we're doing p of 2, that was given as this table of values. Here are my t values up here. So the top row is my input. If you go over to where we have an input of 2, you see the corresponding output is a 0. So there's 2 2's in the chart. You have to make sure that you go to the one that appears as an input. Why? Because 2 is inside the parentheses here. So you always go to the input row for the inputs. So you plug in 2, it says you get out 0. Therefore, p of 2 is 0. Again, I think I'm just substituting all of these symbols with the number 0. So here's all of those symbols, p of 2, and I replace them with the number 0. And then what would be left then? The letter G, and then you've got this left and right parenthesis that survives after the substitution. Now I just continue on and I find g of 0. So I'm looking for a point, because g was given to me as a list of points, or a set of ordered pairs. I'm looking for a point where 0 appears as the input. So 0 is in the parentheses, so it's the input, so as a point it'll appear as the first coordinate. So where do I see 0 comma something in this list of points? That would be right here. If you plug in 0, it says that you get out 3. So the fact that this point is on G, I shouldn't say on G, it's not really a graph, it's in the set of G, that point is in that set. So G of 0 would be 3. So I started with the question G of P of 2, and again, I've been saying it, but I haven't been writing it. If this was a test question or a homework question, you'd be wise to write the original question, your final answer there, so that it's clear that you know what 3 is actually equal to. What did we find? We found G of P of 2, and all of that came out to be the number 3, and then that's basically the end of the problem.